The Earth could leave the Sun. It isn't anchored to the Sun. It's balanced, moving at the right speed to hold an average distance of about 150 million kilometers. Fast enough not to fall inward, slow enough not to drift away. A balance maintained for 4.5 billion years without ever being guaranteed. That balance is the difference between everything we know and absolute darkness, between oceans and ice, between sky and void, between a world where something can live and breathe and look up, and a frozen tomb drifting through the dark between stars. That balance could break. We know this because it has already broken billions of times across billions of worlds that once had what Earth has: a star, a distance, an orbit, a balance, and then lost it, violently, cast out into the darkness with no way back. We call them rogue planets, and they are everywhere. Tonight, we're following the worlds where the balance broke and asking the question no one really wants to ask. What if the balance broke here? Let's begin. A rogue planet from the outside looks like most planets, rocky or gaseous, roughly spherical, moving through space, except it isn't orbiting anything. A rogue planet has no star. It moves through interstellar space freely, following the gentle curve of the galaxy's gravity, but circling nothing, held by nothing. Some are small, Earth-sized, rocky. Some are enormous, Jupiter-class gas giants, hundreds of times our mass. All of them moving through the dark at tens or hundreds of kilometers per second. All of them cold, all of them lightless. But here's what matters about rogue planets. It isn't what they are now. It's what they were. They were planets, orbiting stars, receiving light and warmth. Some of them may have had liquid water, atmospheres, the conditions we associate with possibility. They had what Earth has, and then they lost it. That's what a rogue planet is. Not just a world without a star. A world that once had one. Planetary systems are violent when they're young. Planets don't form in stable orbits. They migrate, they shift, they interact, and sometimes, often, they throw each other out. Here's how it happens. A young star system, planets still settling, orbits overlapping and shifting. Two planets drift too close. The larger one, usually a gas giant, exerts a sudden, overwhelming gravitational pull, a slingshot. The smaller planet accelerates, violently, until it crosses the threshold. Escape velocity, the speed at which the star's gravity can no longer hold it. And then it's gone. Imagine what that moment is like. You're a planet, orbiting a star, warm, stable, and in a matter of hours, days at most, everything changes. The encounter is brief, but the forces are overwhelming. You're pulled sideways, accelerated in a direction you've never traveled, flung outward at tens of kilometers per second. The star, Your star, your source of everything, begins to shrink behind you. At first, it's still a disk, still the brightest thing in the sky, still warm. You're moving fast, but it still feels present, still feels like home. Days pass. The disk shrinks to a point, but still the brightest thing in the sky, still the center of everything. Weeks pass. The point grows fainter. You're moving faster than anything in what was once your system. The star is just a star now, bright but distant, one among many. Months pass, years, and then, at some unmarked moment, with no ceremony, it happens. The star you orbited becomes indistinguishable from the background, lost among the billions. You can no longer tell which one it was. The sky looks the same in every direction. Points of light. None of them yours. And you keep moving. The star's gravity, which once held you in a perfect circle, is now too weak to pull you back. You crossed the threshold. There is no return. You'll never orbit a star again. You'll never feel warmth again. The balance is gone. The darkness from here is permanent. This isn't rare. Simulations suggest it happens in most planetary systems. For every stable system we see today, there were probably worlds that didn't survive the early chaos, thrown out before the violence ended, before everything settled. Our own solar system may have done this too. When Jupiter and Saturn were migrating in the early solar system, shifting inward and outward, pulling everything around them into new configurations, the chaos was enormous. Models of that period suggest other worlds may have formed alongside the planets we know. Ice giants, rocky bodies, worlds that began their existence in the same disk as Earth, and were thrown out. They're out there now, somewhere in the galaxy, drifting, formed from the same material as Earth, born from the same star. Siblings, in a way, separated before the solar system had even finished forming. While Earth stayed, held its balance, settled into its orbit, grew its oceans and its sky, they drifted into the dark. We don't know where they are. We will almost certainly never find them, but they exist. Orphans of our own sun, moving through the galaxy right now, carrying in their geology the same signature of elements as the ground beneath your feet. The balance broke for them. It held for us. Out in interstellar space, away from any star, a planet becomes something else entirely. The oceans freeze. The surface temperature drops toward a few degrees above absolute zero. Colder than Pluto, colder than anything in our solar system. The water at the surface crystallizes first. Then the cold works downward. The ice thickens, meters, tens of meters, eventually kilometers of it, pressing down on what were once open seas, compressing the water beneath into exotic forms of ice we barely have names for. The atmosphere follows, the gases that make up the sky, oxygen, nitrogen, everything that carries sound and scatters light and makes the horizon blue, begins to condense. They cool past the point where gas can remain gas, and they fall. Not as rain, as snow. A silent, surreal snowfall of frozen air. Oxygen crystals drifting down onto a surface already buried in ice. Nitrogen settling in mounds, the pressure dropping as the sky empties. And then the sky itself is gone, diminishing over months until there is simply no atmosphere left. Only ice where the sky used to be. What remains is a world in total silence. No wind, because there is no air to move. No weather, because there is no water cycle. No sound of any kind. Not the movement of water, not the settling of rock. Nothing. A world that perhaps once had storms and tides and the noise of living things, reduced to a dark sphere drifting through an absolute darkness. No light bright enough to cast a shadow. No star close enough to warm a single square meter of surface. Just void in every direction. Forever. This is what most rogue planets have been for billions of years. While Earth had oceans and life and sky, they had this. And they'll have it for billions more. Long after the sun dies, long after every star we can see tonight has burned out and gone cold, rogue planets will still be drifting. Silent. Dark. There is one exception worth holding on to. If a rogue planet kept a moon, if tidal forces kept flexing its interior, generating heat from within, a liquid ocean might survive beneath the ice. Enormous pressure, total darkness, but liquid. Warm enough, perhaps, for chemistry, for something. A hidden cradle in the dark, warmed by the planet itself. We don't know if that's happened. We may never know. But for most of these worlds, there is no exception. Just ice and silence and a drift through darkness that will never end. For most of human history, we had no idea these worlds existed. They're invisible, too cold to radiate heat, no starlight to reflect. They don't announce themselves. How do you find a ghost in the dark? For the young ones, recently ejected, still radiating the heat of their violent birth, we look in infrared. PSO J318.522, a Jupiter-class wanderer 80 light-years away, was found this way. The Euclid mission has already detected newborn outcasts still glowing in the stellar nurseries of Orion. But these are the exceptions. The ancient ones, the billions, are invisible unless they pass directly between us and a distant background star. When they do, their gravity bends that starlight around them. The star brightens, briefly, for hours or days. A flicker. Then nothing. The ghost has passed. This is gravitational microlensing, and it's the only window we have on the true population. In early 2026, we crossed a threshold. By measuring the same microlensing flicker simultaneously from Earth and from the Gaia spacecraft, about 2 million kilometers apart, astronomers calculated a rogue planet's mass directly. For the first time, we didn't just detect a shadow, we weighed it. The Nancy Grace Roman Space Telescope, launching as early as late 2026, is designed to find thousands more. A census, finally, of the invisible population. Whatever numbers we have now, they're expected to rise dramatically when Roman begins its survey. When astronomers first started finding rogue planets, they assumed they were rare. A few million scattered through the galaxy. Curiosities. The numbers kept changing. More surveys, more detections, better simulations. Hundreds of millions, billions. Some models now suggest rogue planets could rival stars in number, especially at Earth mass and below. 200 to 400 billion stars in the Milky Way. Possibly as many rogue planets. Possibly more. Let that settle for a moment. For every star burning in the night sky, every point of light we've ever named or navigated by, there may be a corresponding world drifting in the dark, invisible, moving through the space between stars with no warmth and no destination. The galaxy we thought we lived in, a cosmos of stars, of planets orbiting in warmth and order, is not the real galaxy. The real galaxy is mostly dark, mostly cold, mostly filled with worlds that have been expelled from their homes and will never return. We orbit a star. We have liquid water. We have sky. That makes us the anomaly. In a galaxy of orphans, Earth is the exception, not the rule. We look at these exiled worlds and feel a distance from them. We're safe. We have a star. We have an orbit. We have about 150 million kilometers of balance that's held for 4.5 billion years. But we're not anchored. We're balanced. And those are different things. If a rogue object, something the mass of Jupiter, drifted through the inner solar system, the encounter would last days, maybe less. But the gravitational disruption could be enough. Earth's orbit would shift. Its speed would change. And if it crossed the threshold, 42 kilometers per second, the escape velocity from our position in the solar system, it would not come back. Our star would begin to shrink. First a disk, then a point, then just another star among billions. Then nothing. The oceans would crust with ice within weeks. The atmosphere would begin to fall within months. Oxygen and nitrogen condensing into snow, settling silently onto a surface already freezing. The sky would disappear. Life would not end all at once. Near geothermal vents in the deep ocean, some things might survive for a while, warmed by the planet's core. But the surface would be unlivable. And eventually, even the interior would cool, and the last warmth would go. Earth would become what billions of other worlds already are: a frozen tomb in the dark, drifting through the galaxy for billions of years, carrying the preserved record of everything that once existed here. Every ocean, every mountain, every creature that ever breathed or moved, perfectly preserved, perfectly silent, forever. This is extraordinarily unlikely. The probability of such an encounter is vanishingly small. But it has happened billions of times to worlds that had no reason to expect it either. Worlds that had what we have: the distance, the warmth, the balance, until they didn't. $150 million kilometers. That's the distance. Earth to Sun. The balance point. The number that separates ocean from ice, sky from void, everything from nothing. It doesn't feel fragile. The sun rises every morning. The oceans hold. The air holds. We have no sensation of the speed we're traveling at, or the precise balance that makes it all possible. It feels permanent because it has always been there, because we have never known anything else. But out there, in the darkness between stars, are billions of worlds that once had a number too. A distance, a balance, an orbit maintained at the right speed. Some of them may have had oceans, skies, time, the conditions for something to begin. And then the balance broke, and everything froze. And they've been drifting ever since, carrying the record of what they were into a darkness that will never lift. They are what we could become, and we are surrounded by them. Right now, orphaned worlds are passing within light years of Earth, moving through the space we call empty, invisible, uncountable. Each one a world that lost its star and never found another. We are not one of them. Yet.